Module 8, Resource Management and Monitoring. Lesson 4, Monitoring Resource Use. After this lesson, you should be able to use performance tuning and resource monitoring tools, use performance charts to view and improve performance, and monitor the key factors that can affect the VM's performance like CPU, memory, disk, and network bandwidth use. Performance tuning methodology. You can use these best practices to tune your vSphere environment, assess performance. You can use the appropriate monitoring tools, record a numerical benchmark before you make the changes. Identify the limiting resource, make more resources available, like allocating more CPU, more memory. You can reduce competition, moving the VM to another host, log your changes, and then benchmark again. And this warning here, do not make casual changes to production systems. Resource monitoring tools. To monitor guest operating systems, Perfmod DLL and Task Manager, that's what you'd use on Windows. Linux, you'd use Top and MemFree. Outside of the guest operating system, you can use the performance charts in vCenter Server. If you have the license for it and have it, vRealize Operations. You can use Hyperion. You can use the vSphere and ESXi system logs. And on the ESXi console, our ESX Top and ESX Top will give you performance counters. Here's an example in Windows using Task Manager. As you can see in this example, our CPU usage is 100% of the guest. Using Performance Monitor in Windows, you need to snap in the Perfmod DLL. You need to have VMware tools installed on the guest to use this. And as you can see, we can pick counters and objects such as percent processor time, limit. You can add those on what you want to see, and it'll show you in the Performance Monitor report. Using ESX Top, it's a real-time monitoring tool. And when you're on the command line, you would just type ESX Top. And as you can see, it's showing us 3 VMs. And we can see the VM names on the output below it. And it'll tell us the statistics. You can also switch around if you hit C and uppercase V to view CPU metrics. And that's what it's showing us in this example, the CPU metrics. This is based on the Top utility from Linux, but they call it ESX Top, and it's customized for VM operations. The vSphere subsystem collects data on the resource usage of inventory objects. This is your counters and metric groups, the collection levels and collection intervals, and the data availability. And this is an example report of what you'll see in vCenter. Working with overview performance charts, they will display the most common metrics for an object in the inventory. Advanced performance charts, this is where we can pick the metrics that we want to show and what kind of output chart we want. If we want it to be real time, or do we want to see historical what it's doing. And then we can pick our counters. And again, chart options can be real time or historical. Chart types, you can do line, bar, pie, or stacked. And then we can save the charts, and you can save them in a PNG, JPEG, or CSV format. The performance charts graphically display CPU, memory, disk, network, and storage metrics for devices and objects managed by vCenter. The objects and instances or aggregations of devices. Examples of that is you can do the CPUs. In this example, VM-HBA1, so you can do a host bus adapter, or you can aggregate it over all the NICs. statistics type. This is the unit of measurement that's used during the statistics interval. So we can have a rate, a delta, which is a change from the previous interval, and we can have absolute. And this is actually what it's doing. So like memory's active, it's going to be using 4 gigs of RAM. That's absolute, that's not going to change. Rollup is the conversion function between statistic intervals. So rollup type would be an average. That would be your average of data points of, let's say, CPU use. We can do a summation, which would have, the example here is CPU ready time. It would add them all up. The latest is the last data it is collected. Other rollup types would be your minimum and maximum. You can set log levels, and this is how verbose the log output's going to be. So if you set it to none, no error, no logging errors, but only going to show us, or only show us logs with errors. Warning would be errors and warnings. Info is just normal logging. It will display information, error, and warning. Verbose displays information, error, warning, and then verbose log entries. And trivia is an extended verbose. It basically is going to show you everything that can be logged. Interpreting data from the tools. So in this example, as you can see, the guest OS is using 100%, but when you look at the chart, the CPU is not. So this would tell us we need to add another CPU because the guest is being constrained, but the host has CPU available. A CPU constrained VM, this is when CPU is continuously high, but the host might have enough CPU for other virtual machines to run. Multiple VMs that are constrained by CPU if the high CPU usage in the guest OS and a relatively high CPU ready values for the virtual machines. Memory constraint, you can check the VM's ballooning activity to see if it's constrained for memory. If ballooning is high, this might not be a problem if all the virtual machines have sufficient memory. If ballooning is high and the guest OS is swapping, then the virtual machine is constrained for memory. A memory constrained host is when the active host level swapping occurs and the memory is overcommitted. So basically our ESXi server is using all of its memory. Monitoring the active memory of the VM, you want to monitor for increases in the active memory on the host. The host active memory refers to the active physical memory that's used by the virtual machines in the VM kernel. If the active memory is high, this might lead to virtual machines becoming memory constrained. Now we'll talk about disk constrained VMs, and we can have disk intensive apps that saturate the storage or the path. If you're suspicious that a VM is constrained by disk, then measure the throughput and latency between the VM and the storage. So, and again, you want to look at the path of what it's going through to see if it has enough bandwidth. You can use advanced performance charts to monitor the read rate and write rate, the read latency and the write latency. Two things to monitor for disk latency in the data counters. The kernel command latency, and this is where the kernel sends the SCSI commands or whatever storage commands, and how long does it take to come back. If it's a high number, greater than 2 or 3 milliseconds, then you might have an overworked array or an overworked host. The physical device command latency, this is the average time the physical device takes to complete a SCSI command. If these numbers are higher than 15 or 20 milliseconds, you would have an overworked array or an overworked host. Network constrained VMs. This is when you have applications utilizing the networks. It could be bottlenecking a segment, but this would be outside the ESXi host. Example they're given here is WAN links between a server and client. If you suspect a VM is constrained by the network, make sure VMware Tools is installed, because you'll get an enhanced network driver that has better performance. Measure the effective bandwidth between the VM and its peer system, and then check for dropped receive packets and dropped transmit packets. You should be able to use the performance tuning methodology and resource monitoring tools, use performance charts to view and improve performance, and monitor key factors that can affect the VM's performance, such as CPU, memory, disk, and network bandwidth.